Hello, everybody. Welcome to OpenCV Weekly Webinar. I'm Satya Mallick, and today we have with us Joseph Nelson, who is the CEO of RoboFlow. RoboFlow is one of the silver partners of OpenCV. They support us, but every time Joseph has shown up on the show, he has provided a lot of value. And today we are going to discuss a very interesting topic, which is what's really inside the COCO dataset. Probably everybody here knows about the COCO dataset. Even if you have not heard about it, we will go over what the dataset is about, but then we will explore what's really inside the COCO dataset. It's going to blow your mind. But before we go into the actual presentation, I want to invite Phil Nelson, who is the director of content and creative at OpenCV. He hosts this show, he organizes this show, and if anything goes wrong, he is responsible for it.
Yeah, it's a lot of pressure, but I do my best here. Good morning, everybody. I am Phil Nelson, once again, your co-host with the co-most, the second banana who is second to none. I am also your plus one and only, and I'm here to remind you of a few things we do every single week here on OpenCV Weekly Webinar. This is episode 80, if you can believe that. The first thing we do here is Q&A from you in the audience. Please use the little button on Zoom if you're watching on Zoom to ask your question at any time during the show, and we'll do our best to flow it into the conversation. We've also saved some time at the end to answer those questions we don't get to. Ask your question in the chat wherever you're watching. We'll try to get to it. We've also got a special giveaway of a RoboFlow swag pack from our friends at RoboFlow and our guest Joseph. Stay tuned for how you'll be able to win that later in the show. It's not going to be our standard trivia. It's going to be a little bit different, a little more participatory. But now, on with the show. Satya?
Well, welcome again, Joseph. The show is all yours. After about 15-20 minutes, we'll also have some other announcements. We have the OpenCV face recognition. We have an announcement about the competition. But I just want to get started with the show first because there's some exciting stuff here.
Well, pleasure to join you, Satya and Phil. Thanks again for having me. We always do have a fun time on these, and it's really a pleasure of mine to be a part of what you all do for the community with the OpenCV Weekly Webinar.
Oh, shucks.
Is it true that Joseph, that Phil and you are brothers, and that's why Phil keeps inviting you?
Lies and slander. Lies and slander.
Yeah,
and bad.
No, I mean it's a pleasure to be here. We do our earnest in terms of putting together novel and sometimes breaking news content, like on today's show, of what we aim to do and bring. So it's really a pleasure to be able to share that with you all and the community that joins us. We did a nice round of introductions here. As noted, I'm Joseph, the co-founder and CEO at RoboFlow. We make computer vision developer tools, make it easy for engineers to add computer vision to their products, from image to inference, video, images alike. I always introduce the OpenCV team, even though it's their webinar. I feel like they should have the opportunity to brag about the incredible impact that OpenCV has for the community. I'll do it on their behalf. I mean, for 20 plus years, OpenCV is a leader, maybe the leader in terms of downloads, over 1 million a week, I think it is, of getting engineers, developers alike into computer vision and image processing generally. And the OpenCV team also does a great job of providing support through courses, community, and hardware partnerships, including things like the Lexonis Oak OpenCV AI Kit devices. RoboFlow and OpenCV share a pretty common goal in terms of enabling more developers and greater access to computer vision. As a part of that, you'll recall that we introduced a course that's you can enroll in for OpenCV and RoboFlow for doing active learning with computer vision, of basically ensuring you can have higher quality models with fewer images more quickly, which always is a plus. Phil or Satya, I don't know if there's anything to add to how I did with the OpenCV.
Where can people sign up for this course, Joseph?
On the OpenCV website. OpenCV.
Yeah, it's part of actually multiple courses. This is what we call a mini course when you take OpenCV for deep learning with PyTorch or deep learning with TensorFlow and Keras, you get this course for free as an add-on.
Cool.
And it walks you through the RoboFlow pipeline, active learning, which is very important when you're building real-world applications and having something deployed and getting that learning in from real-world data back into your already trained model. You want to keep refining your model, then it's very important. And as always, it's a short but very educational course.
Yeah, these days it's all about the data and your custom data, and RoboFlow makes it easier than ever to get that in there. So check it out. OpenCV.org/courses.
The other thing I wanted to mention is that, like I already mentioned, RoboFlow is a silver partner for OpenCV, and it's a donation. They don't expect anything in return, and that's in the spirit of helping open source communities, right? And we do a lot of other work with RoboFlow just because it's an amazing tool. And I cannot say enough good things about Joseph and his team, because we share common ethos. It's that you provide value for free to the open source community. And if you go to RoboFlow, they provide a ton of tutorials, even on things that may not be related to RoboFlow itself. In general, computer vision, machine learning, they give out concepts, they talk about new architectures, etc. So it's a really good place for the community members to visit and also use the tool. But amazing job there, Joseph.
Yeah, like you said, we have common goals around the community, and a bigger community benefits everybody. A bigger, more welcoming, more inclusive community. Rising tide raises all boats.
So OpenCV is launching OpenCV face recognition in collaboration with 7sense. It's the state of the art. It's very close. It's doing very well on the NIST competition, and this is we have a lot of free stuff on OpenCV, but this particular feature would be a freemium model, because you really cannot have a state of the art face recognition system which is completely free, right? Because these things keep evolving. We have to put a lot of time and energy and resources in just the face recognition part. That's why we partnered with 7sense to bring a freemium model to face recognition. And Phil, you would be able to, is there a link we can share right now where people can sign up?
It is in fact on the front page of OpenCV.org right now. They can go check it out. That's
great.
OpenCV.org.
Yeah, so if you sign up for this, there would be 100 winners who would get premium access to this service. We are going to announce what the service is going to look like in just a few days. So stay tuned. It is going to be game-changing for you if you want to use face recognition verification kind of in your own application. And of course, you have to use it responsibly. Otherwise, this thing, both in terms of licensing and and our ability to shut down applications which are which are doing nefarious things. It's very easy for us to do it. So please use it responsibly. But I really want you to go and try it out. We want to be always at the state of the art. And this is our opportunity to make some product which is really good for the community and very close to the state of the art. And the reason I say that it is very close and not exactly at state of the art is that the companies keep switching. NIST, I think the competition, the results are updated every 4 months or so, and so there is always this thing going around back and forth. There are like top 10 teams which keep swapping places, but it was in the top 10 in March, and we are waiting for the latest results. Try it out. It's going to be amazing, and you can build a lot of interesting features. If you're a student, you can actually build a student attendance system using OpenCV face recognition with just a few lines of code. right? And we'll give plenty of examples when we launch.
Great. Yeah, stay tuned to opencv.org for that. The best way to get the latest news on that would be to subscribe to the newsletter, opencv.org/subscribe.
Awesome. So diving into the last little notes on the notes of community and some of the tooling we shared about OpenCV, give you a little bit of context about the tooling that we work on at RoboFlow. Everything from, we say, image and video to inference.
Mm-hmm.
So collecting data, organizing that data, figuring out what to annotate, annotating it, maybe working with third-party annotation providers or other even annotation tools, CVAT, some of these other open source opportunities, processing images, doing augmentation, training those models, and deploying those models to the best state-of-the-art target. As it relates to some of the community piece, and this is where you all come in, when you are creating public data sets and public workspaces, it allows everyone else in the community to benefit. And now RoboFlow Universe is actually one of, if not the, I think, largest collection of computer vision projects on the web today, with a little over 66 million images. Has actually crossed 100 million images even since this slide was created. Over 90,000 data sets and over actually 11,000 pre-trained models.
Wowzers.
For everything from finding sheep from aerial footage of drones to detecting faces to doing pill identification to license plate recognition and everything in between. And let's talk about how that impacts some of the work that we're going to do today with in the context of the COCO data set. So with that in mind, and with the
there's some big numbers on RoboFlow Universe in a short amount of time. Congratulations to the RoboFlow team and community on that.
It really is the community's effort that's powering this. And so we're doing our best to ensure that the community is well supported with the tools that they have to be able to be successful. But ultimately, I think the viewers and the folks that are tuning in are certainly the ones to be credited. And we have a bit more to say about that, actually, in the context of COCO.
Cool.
All right, Satya. So we're ready for the main event here, all about the COCO data set. So I was sending Phil some funny images.
Yes.
Maybe the funniest part about that was Phil wasn't surprised. He's like, "Oh yeah, more funny images." And so I let Phil know. I said, "These images are actually from the COCO data set.
Yes.
You kind of have, and I don't want to spoil them, but there's things that you might not be able to predict with aluminum foil and saran wrap and animals and costumes and all sorts of goofy things that are about the COCO data set.
Something you might expect to see on OnlyFans instead of COCO. Like, yeah.
So, but it would be, I mean, there are some people who may not even know about the COCO data set. If you could just explain in a few
It's true.
In a few lines, what is the COCO data set and why is it a benchmark, etc.
Exactly. Yeah. So we're going to start with the highest level, 30,000 foot. What is this thing? And then why is it significant that there's weirdness going on? So the COCO data set, some key background. COCO is actually an abbreviation for Common Objects in Context. It's one of the most infamous data sets in computer vision. And it contains images and labels for a variety of different tasks, everything from classification tasks to object detection to segmentation to key point to captioning-based tasks. It was introduced by the Microsoft research team originally in 2014, and then a revised version of the paper and data set was released in 2015. And so it's coming up on almost a decade here of being a hallmark data set in the computer vision community. There's over 300,000 images in it, over 200,000 of which are labeled, which makes it be a really, really useful way to say, how is my model doing? Let's test it against the COCO benchmark. So on the right, you see, of course, just a quick screenshot of the COCO paper. And I think if I switch tabs, you'll be able to see. Yep. So, I mean, here's the original publishing, as I mentioned, in 2014, and then in 2015, and of course, the PDF fully available. And as you can see in the abstract, the authors say that they wanted to have 91 object types recognizable by what they say a 4-year-old. So it gives you like a context of, if you think about it, computer vision has increasingly only gotten better with the types of things that we can see, observe, and now you have computer vision models that regularly perform better than subject matter experts in a given domain, right? Better than doctors in some cases, better than contractors of identifying maybe construction parts or these sorts of things. And so the COCO data set does a really good job of basically being like the foundation of things that you could explain to someone quickly chairs, person, these sorts of common objects. And to that end, I say, okay, so what's in that data set? So I thought maybe it'd be useful to zoom in on what's in the data set in the context of just, for example, like object detection. So I'm going to jump over to, here's a list of the classes and their relative balances. This is a snapshot of 5,000 images in the COCO data set, which is a common subset to work on for quick iteration, quick model prototyping, and it's called COCO 5K. And so you can see that, of course, there's quite a few person classes in here: car, chair, book, bottle, cup, dining table, cow, sheep, surfboard, zebra. And these are all meant to be things that you might see, and again, that perhaps a 4-year-old could learn. And if that 4-year-old is in San Diego, they're probably more likely to know surfboard than a 4-year-old in Iowa. But, I digress on the included classes along the way.
Corn.
So, yeah, there's no... I don't think there's corn actually in the data set, which is a huge miss.
Yeah.
But yeah, so the data set when it was introduced, of course, when you create computer vision models, you need to know how those models do. And it's no good if Phil trains a model on a data set of photos that he captured, and I train a model on a data set of images that I captured, and there's no commonality to say which of these models actually performs better. Either I need to go train on Phil's data set, or Phil needs to train on my data set. And so what the COCO data set did is it became that like one of the most common central benchmarking data sets in computer vision. Since then there's been data sets like Objects 365, and other data sets that have been introduced for additional benchmarking purposes. But nonetheless, just by virtue of having been first, large, open source, and commonly known, it's become increasingly a really useful way to assess the performance of how a given model is doing. And so in research, a lot of the times we hold the data set constant and we iterate on the model architecture. COCO kind of becomes one of those data sets you hold constant to iterate and test on how your model architecture does. And so a lot of the times when you see something declared state of the art, usually that benchmark is on the COCO data set to say this is the best that we've done so far for this type of task on the COCO data set.
Yeah.
Ubiquity makes it even more useful is sort of the short way of saying that, right? Like it's an apples to apples comparison model wise when you're using the same common data set.
Right. And it's also for several, there are a few things going on, right? It is a very large data set. It is for a large number of tasks, not just for a single task. And once it becomes a benchmark, right, it becomes unfair to judge old ones. You have to judge the old algorithms with the new ones. And sometimes you don't have the code or the model for the old one. And so this kind of sticks. But it's a very diverse and good data set, very large data set, and everybody uses it. So, good one to use. And again, COCO 5K is another one that you use when you want to quickly iterate on things.
So, so COCO 2017 is kind of the refreshed and most common one. As we mentioned, it was released in 2014, updated in 2015. COCO 2017 has been the most recent update to data sets of production. Now, what's interesting is because a lot of the times, researchers and those that are working on model architectures are spending their time on, okay, I've got a data set and I can just trust that the labels are good, and whatever Phil used, I can use. So I presume that the data parse, that piece is handled. I'll focus my time on figuring out how to improve my model architecture, which actually, now that we've gotten better tools for exploring data sets, has resulted in some kind of maybe funny oversights. So I like to say what's in the COCO data set, but now I like to say what's really in the COCO data set. And it's at this point in the show that I will introduce a few funny images, and then I will pass to Phil to introduce the competition that will take place for the rest of the show as Satya continues through the content. So to tease a little bit here, what's really in the COCO data set, there's things like this. Of this man who is, I suppose, cuddling with a horse.
Too hot for TV.
I mean, maybe the most upsetting thing here is the mattress without sheets, but quite a few
no pillowcase on that
questions
thing.
to be asked And then you got this here, where this individual has, I believe, donuts saran wrapped to him. I presume maybe this is a Halloween costume or something of sorts. I hope.
There it is. Wow. Yeah. Are they donuts? They almost look like rare earth magnets. Maybe this is some kind of, homeopathic therapy or something.
We may never know. Or you've got this guy, and a crowd of people dressed like a dog next to a large fire hydrant. You can see all the classes that are kind of labeled of all the people nearby. That
looks like that's from the show Wilfred, which was actually pretty funny. At least I saw the original version. It was not bad. This guy has it's based on a movie from like the 40s that this guy has an imaginary friend essentially. It's good. Yeah.
I would trust that Phil would have the trivia knowledge to help us reverse engineer these images of anybody. Phil would be the guy.
Yeah. Also, that's Mike cuddling with the with the horse. I know that guy.
So this was also before Stable Diffusion became a thing. Mm-hmm. Because now you can generate these images by just saying that man with donuts all over his body, and you will probably get some image like that.
Probably.
You're right. It would be interesting to compare and contrast these with Stable Diffusion generations. So the joke that I've been wanting to make here this entire show is, the COCO dataset is called Common Objects in Context. But as we can see, these are common objects out of context as we take these images.
And maybe not so common either.
Maybe not so common. Uncommon objects out of context.
Yeah.
Here you have a dog and its friends going along for a ride. And before I continue with additional kind of shock factor, I actually want to introduce something, and I'm going to pass it to Phil so that you can also do this. Mm-hmm. So one of the ways that you can explore the COCO dataset, as noted, is you can look at the COCO dataset explorer. But what's notable is the COCO dataset explorer only looks for things when you actually type that specific class name. So if you look for stop sign, then it's going to find stop sign. Mm-hmm. However, maybe we want to semantically index and understand the dataset. And so the dataset, the COCO 5K, for example, is here hosted on RoboFlow Universe. And on RoboFlow Universe, and this is the link Phil will share in a moment, you'll be able to actually go in and you can make a semantic search. So for example, there is not a class for Santa in the COCO dataset, okay? But if I look for Santa in the COCO dataset 5K, and I use semantic search that knows the concept of Santa and matches what it believes Santa is against every image in the COCO dataset, in fact, what do we get?
Wow.
We get some Santa-looking images and
Santas.
some weird ones at that.
So Joseph, is this semantic search part of the original COCO dataset, or is it something that RoboFlow has additionally added tags to the dataset?
It is something that RoboFlow has added as a part of quality to the dataset. So for example, here's a really good example. Santa here in the back of this truck is not labeled. And us searching the word Santa actually allowed us to find this image. And so the RoboFlow indexing is intelligent to know and look and find the terms that we're looking for. So for example, here's a teddy bear that looks like Santa. And semantically, that's in a similar, the image encoded here is in a similar space, the concept associated with Santa. And what we're doing here is actually, you can do this with any actually data set on Universe inside the data set or across projects. So for example, like one thing I like to do is I like to look for, like I did sharks from aerial imagery, right? And so this is maybe, if you find a shark, it'd be like a drone view of a shark. And I actually searched that. And in fact, there are some public projects of folks that I've worked on, you guessed it, finding sharks from above. There's actually some pretty scary images in here because there's some of them. Yeah, here.
Super close to people. Yeah.
Here's a shark.
Gosh.
Or like, I don't know, cars on the street in New York. I can semantically search something this rich and data sets that appear to be most New York friendly. will come up here and we'll see if this is, that's definitely New York. So the in the COCO data set here, we can actually search within a given data set, which is what we're going to do and kind of tee up our competition.
Yep.
So, like in the New York one, if I want to look just in the New York one, I could say taxi.
Yeah.
And then I would find all the images that are, only that's actually not even a yellow taxi. New.
That's actually a very useful feature. You get the benefit of the COCO data set, but also things that are not completely labeled in those data sets. So that's really useful.
Yeah, very interesting.
Exactly.
Yeah.
Exactly. And so, obviously you can use this to maybe pull images out of COCO for something you're looking for.
Yeah.
I could go in here and if I wanted these images, I could go ahead and actually select these, and I could clone just those specific ones to one of my workspaces if I wanted.
Yeah.
Or of course I could just download just export the whole data set if I just want to download this whole thing.
How many results does it return when you type in Santa?
So it looks through everything.
Yeah.
So it'll index all of these images, but we can scroll to see how many when they stop looking Santa-like page by page here.
Oh wow. Okay.
I mean, even this is somewhat Santa-like. I have to give it credit.
It's not Santa.
It's not Santa-like. So I'm gonna give Phil the pleasure of introducing the goal here of the. You can probably get an idea of where this is going with the competition.
Yeah, so our giveaway this week of a RoboFlow swag bag will be decided by who can find the weirdest stuff in the COCO dataset by searching semantically on RoboFlow. The link is now posted in the chat. Good luck to everyone out there.
I'm excited. This is exactly what the community is useful for. People's different creative ideas. If I look for Phil Nelson in the COCO dataset, what do I get?
I'm scared. I didn't look. I don't want to know.
There you are, Phil.
That's a part of my life that I would.
Oh, that's you, Phil. That clearly looks like you.
Just like me. Was that Is that Baron von Raschke?
I mean, you don't.
That
see
may
the
actually be me. No.
It's your future.
Oh.
Wow.
Phil, you're a snowboarder. That's cool.
Yeah.
Oh, that's
definitely.
Yeah.
It looks just like me. So yes, folks, during the show here, while the presentation is going on, follow those links and semantically search through COCO for the weirdest search term. Whoever sends the best one into the chat will win our RoboFlow swag bag, which we'll announce at the end of the show. Good luck to you, and may God have mercy upon our souls.
So I am going to maybe steal some more from the submissions because there's a few more weird ones I want to introduce for inspiration, and maybe this will get you going for what to search for. I think the search term for this one was related to finding costumes and fire hydrants, and this one was
So you found all of these. You found all of these using the semantic search you're talking about.
That's exactly right. We found all of these using semantic search. And just so people don't think that we're cheating them, the ones that we've already found are here
on that blog post.
The weirdest ones. Yeah. So if you find one that's already in the blog post, we won't count it. It has to be even weirder. So let me jump over to some more weird images that we found one by one. I like the shock effect of one by one.
Yeah.
So this is presumably a dentist vehicle. With all the toothpastes stamped to the bumper.
Yeah.
Here we go.
Chew Brew is what the license plate says. I don't know. Wow.
This is what you call when the dentist has gone all in, right?
Yes, right, exactly.
Every aspect of his life, the nameplate, the whatever, every aspect of his life is around the service he provides. He's gone all in.
Probably one of those weirdos that gives out little tiny toothpaste and toothbrushes on Halloween. I hate those guys. Hate them. Still mad about it. It's been 25 years since I went trick-or-treating. And yes, we've got our, this is, to me, is the weirdest one I've seen so far. It just, like, I mean, I guess it makes sense, you know, but, yeah.
I don't know. I don't know whether it makes sense.
I mean, if you're detecting dogs and cattle, maybe, I don't know. I don't know.
This one is a little more creative.
Wow. Yeah.
Got a guy on a boardwalk wearing a watermelon costume, I suppose.
A banana hammock and a watermelon hat.
This one is a grad project gone wrong.
Wowzers. Yeah. It's
our spring break gone right.
Jambi got on the juice. Make a
so these are the weird ones that we've kind of teased out from different ideas of at least COCO 5K.
Now tell me, what were you searching for when you discovered this image? I'm really curious. What kind of search terms do you use?
A good magician does not reveal their secrets. You don't have to answer that.
I actually don't recall the specific search term for this one.
The fifth, I see.
As a team. Well, so here's why. As a team, we all kind of did this exercise internally, and so I'm not the explorer that surfaced this image specifically. Though I'm sure I can ask. I think Trevor on our team.
I was going to say name and shame them. We don't let them get off on this show. Name and shame.
I think it was Trevor.
All right, Trevor. We're on to you. Tremendous.
But yes, I mean, jokes aside, I kind of wanted to talk a bit about the while we do the discovery of the COCO dataset. Like, we talked a bit about like what it is and why it's been important. I do want to talk about it as a benchmark to some degree. So, for example, every time a new YOLO or one of these models comes out, you'll see that there's a rush for people to show how good it is on COCO performance. And so here's when you see these graphs, what has happened. You see that the mean average precision for an object detection data set is plotted on the y-axis. And then the inference time is plotted on the x-axis. And so every time a researcher is aiming to identify the quality of their model, they are looking against the COCO benchmark. And COCO has validated test sets that are standardized and useful. So here's just a snapshot of current state of the art, right? So you got YOLO v7, YOLO v5, scale YOLO v4, YOLO X, PP YOLO, YOLO R. These are only of the YOLO family, of course. There's additional models, but at least of single shot object detection models on a speed versus Pareto accurate efficient axis. This is kind of what you get from where the utility of the data set comes into play.
Cool.
And notably, so at this point, I think it's actually useful to start to discuss the limitations of the COCO dataset. So as we described, it was introduced in 2014, revised 2015, and updated in 2017. I think that there's actually been some limitations that have been found in the dataset that have come to light more recently as models have gotten better. Basically, as the models that we build better understand the world around us, the subjects that they're learning about and the optimizations of those architectures could be based on the things that you're trying to find. So let me give you an example. In the COCO dataset, as you saw, a lot of the bounding boxes that we're looking at, generally speaking, these bounding boxes are, pretty, I would call it like regular square or, near square, like rectangle shapes for the most part. Yeah. Like the average bounding box in this data set is, like probably rectangular on average sort of shape is how I would describe it. Now, why does that matter? Well, imagine that you are building a computer vision model and you're finding Phil's favorite object, toothbrushes. And toothbrushes are always, kind of longer than they are tall. And if you're trying to find toothbrushes, those bounding boxes are always going to be pretty oblong in shape. And over time, some architectures, especially for example, in the YOLO family of models, will be based on anchor box optimizations. An anchor box is where where across the image the model looks to place and seek for finding where a given object could be detected. And those anchor boxes, like by default, you can just have anchor boxes that are positioned across the image in standard positions. But your data set may have the objects always in maybe one part of the image and always shapes that are a little bit different, which means you can learn anchor boxes that are for maybe like we'll say like the northwest quadrant of the image, and the box is also learned to be predicted of a specific size and shape. And previously, this wasn't really a consideration because our models were so new and
not as thorough, not as robust.
Lacking.
Yeah.
Not as robust. Yeah, thank you. But they're not as robust that small optimizations like this wouldn't have moved the needle. Ultimately, it's like, are you finding the person or not finding the person?
Right.
Yeah. But now our models have gotten good enough that things like this begin to matter, and actually label error begins to matter. The subject similarity of what you're looking for begins to matter. So if you're a researcher and you want to maybe say, I'm finding things underneath a microscope, and you're benchmark it against the COCO data set, this may not actually be perhaps the most accurate representation of a given model's performance on your specific domain. And this is sort of a new thing that's happened. And honestly, we should celebrate this, that we're basically saying our models have gotten so good that the data that we are basing them on should also be more representative of the task that you're aiming to do in production. Yeah. And so basically, I think what we're kind of experiencing is maybe a question of COCO benchmark saturation.
Yeah, that's a very good point. Even the example that you gave, it may feel that it is a contrived example, but it is not. I'll give you a very easy example from a recent project where in retail we want to do shelf detection. And these shelves, there are many ways to solve this problem. If you want to take a picture of a shelf and you want to find where exactly different products are located, you can solve it as a semantic segmentation problem where you find the shelf. But you can also solve it as a object detection problem where you have bounding boxes which cover the entire shelf. And that is a very long object, right? And if you're not careful, then you may, you have to make sure that the architecture you're using, it automatically chooses the long kind of bounding boxes based on your data set. Otherwise, you may not get very good accuracy, right? So it is not a contrived problem that that Joseph had mentioned about Phil's toothbrushes.
Yes, my toothbrushes. Thank you.
Yeah.
And in fact, I think that we've begun to see this latent desire for assessing models on things beyond the COCO benchmark. I'll give you an example. So on the slide here, I have a screenshot from the Florence paper. Florence is a foundation computer vision model that the Microsoft team, Microsoft research team released last November, so about a year ago, actually. And what's notable is you have Microsoft, who of course published the COCO dataset, of course are infinitely aware of everything COCO has and what it doesn't have. And they actually went to look for benchmarking on COCO, but then also benchmarking on other open source datasets to both test zero-shot prediction capabilities of Florence, as well as some of the object detection tasks. And what maybe you can see, or I can read for you here in the text here is, they actually went to public datasets on RoboFlow and grabbed a basket of 11 of those datasets to benchmark against. And so pulling things like chess pieces, pulling things like thermal imagery, pulling things like wildfire smoke, pulling things like packages left on doorsteps, pulling things like cells underneath microscopic imagery to basically ask this question of maybe every object isn't common and in the real world, right? Like not everything is a person, not everything has like a real world view. And how would a model generalize to motor domain specific problems? And so this is, I think, actually some encouraging behavior we're seeing of COCO is still a really useful foundation, and it's going to continue to be a measuring stick, a yardstick. As you start to wonder, okay, what about a specific task? What about a specific type of task? Can I get a bit more robust and specific in how my model does on a narrow domain problem? Whether that's retail, like Satya mentioned, going to the dentist like Phil likes to do, finding the images in thermal imagery, or anything in between. The value of having a domain-specific data set is still is quite high. And we've seen a bit of this interest from the open source data sets that the community has already published on RoboFlow Universe, which brings me to the point that I actually wanted to, so here's actually a snapshot of that image kind of blown up a little bit. So wildfire, smoke, potholes, thermal, aquarium. You can see the blood cell count detection data set, mask wearing, chess pieces, which was labeled by yours truly, painstakingly every single chess piece, and used for some of this benchmarking. Which actually I wanted to give, I wanted to basically ask this question and say, can the community improve our ability to help us measure the quality of our models? And I think, from this latent interest from the Microsoft Florence team, there's another model called GLIP, which was zero-shot object detection, that also came from Microsoft Research that benchmarked on 13 public data sets from RoboFlow in addition to COCO. And so we said, if we're seeing researchers already pull these data sets from the community, what can we do to make that easier? And so we're actually introducing something called the RF100, RoboFlow 100, which RF100 is basically us going through and combing through the data sets that we've seen across the community and saying, what if we aggregate, release, and make available very easily all these different subject data sets for various topics? And so here, for example, you can see that we've just kind of...
This is an extremely cool visualization. I love this.
Yeah.
Thank you. So this gives you context into those 100 different data sets that are in the domain. So they clustered into 7 different topics, which we chose those topics, but we chose those topics based on the topics that we most frequently saw on Universe, which basically the cool thing here is that us implicitly looking at Universe is a sample of what is computer vision being used for today? How are people using vision? And I actually came on this week to give you actually a pre-release, a preprint of the fact that RoboFlow Universe is going to, that the RF100 is going to become available, and kind of a sneak peek, as well as a sneak peek at the paper here.
Ooh.
So
breaking the street date here.
Yeah. So we're thrilled to be able to introduce this, and we'll be submitting it for continued presentation. But RF100 basically is 100 different data sets from the community, in 7 imagery domains, 224,000 images, 829 class labels, and over 11,000 labeling hours were spent. The class, the types of projects that you see were things like everything, as you can hope to see on my screen here, of things like tweets, or the thermal imagery was popular, or circuitry, or everything in between. And those 7 topics included aerial, video games, microscopic, underwater, documents, electromagnetic, and real world. And so I can jump to table 3 where you can see those in greater context. I'm gonna hold back the results of some of the initial testing of models. I'm deliberately going to put this at the bottom of my screen, but you get to see here the each of these different example domains. And what's interesting here is you start to see domains that extend beyond COCO, right? Yeah. Things like underwater images, or documents, right? Document process is an extremely common task in computer vision, but it's not represented in the COCO data set at all. Yeah. Or you have aerial imagery, which is another great example. Yep. And screenshots as well. Like screenshots and screen understanding is another big area of computer vision that is also not represented in the COCO data set. So the last thing that I do want to give a shout out to is every author of one of these data sets is referenced deeply in this paper. And so if you have the opportunity to contribute a data set publicly, and you went in and you chose your license to be MIT CC BY2, you are a part of advancing the computer vision community and enabling more people, more models, more researchers to better understand the performance of things in the future. And so I couldn't be more excited, honestly. Come on.
That's great. Credit where credit is due is something we always love to hear on the show. I feel like a lot of the times these public data sets or open source software, when bigger companies use them, they tend to cut out the people that actually created them. And it's awesome that RoboFlow is doing the opposite of that and actually giving them credit in the paper. I love that.
Of course, because I mean they're not our data sets. Mm-hmm. Like we happen to host them, just like we happen to host COCO. But the owner of the data set has decided to make it available and then choose a license that they basically said, yeah, here's
Yeah,
some work that I've been doing out in the open. And we are in the fortunate position to be able to easily collate and re-release that to the broader community. So if you really want to dive in and see all the data sets in the RoboFlow 100, it's on Universe, universe.roboflow.com/RoboFlow-100. And you can see things: solar panels, soccer players, aquarium, furniture, leaf, chess pieces, digits, BCCD, all the way on through here of various different topics.
Wow.
And again, all the authors are credited of whomever is the publisher, what they chose for their license, the citation for them, and everything therein. So we're thrilled to be able to begin to release this and make it become more common, and hopefully it can have a small impact or big impact, small start, big impact in allowing us to assess how well does my model do on microscopic imagery, underwater imagery, aerial imagery. And we can start to ask not just how do I do in the COCO data set, but how do I do on RF100? How do you do on the video games domain? And therein advance the capabilities of our understanding of vision models.
Such an exciting announcement that you broke your camera again. Come on, Camo, help us out here, Camo Studio.
While Joseph is fixing his camera, I want to add a little bit to it. So this is wonderful. I mean, because when we develop architectures, right? If we develop them for very specific problem domains only, then it becomes problematic. Then they don't generalize. And I cannot remember whether I read it in a paper or I had a private conversation with one of the researchers. I cannot remember, but this was the conclusion. And people should actually do their own research before completely agreeing with me, because this is from memory. I cannot reference where I actually heard this or where I actually read this. What was happening is that if you look in the medical domain, people are using architectures which are like 3-4 years old, right? Why are they not adopting some of the new architectures? Something like efficient net, for example, is a efficient net and efficient det for efficient detection. These are architectures which were tuned automatically for COCO data set, right? And they do spectacularly well. So they, there are ways they optimize the architecture so that it performs exceptionally well on these COCO data set. But I was always wondering that why is the medical community not adopting some of those, and why is there a lag? And based on, I cannot remember the exact reference where I heard this or where I read this, but what I heard was that these, because they are so much optimized for the data set, they are kind of tied to the data set. So they don't generalize when you go to other domains like X-ray and that kind of domain, which is not exactly RGB images. They are slightly different images. Right. They don't generalize as well to that domain, and the performance is actually worse than when we were not creating these optimized, automatically generated models. But use this information with a grain of salt. Do your own research, because I simply cannot remember where I heard this.
Well, yeah, monoculture in data sets, just like in music, like in TV, like in anything, it's generally bad.
Yeah.
Looks like you're back there, Joseph. Thoughts on COCO's ubiquity and how it may actually be harmful in some uses, like Satya was just discussing here?
I think it's true that if you overstate its representative quality, right? I think ultimately, of course, like an enormous step forward for the computer vision community, and the level of effort and research and that has gone into allowing it to be a common benchmark cannot be understated. The places where vision models sometimes get themselves into problem is you claim that the domain you want to use the model is distinct from where the model was trained, right? This is a common known subject similarity shifting issue. And I think it's more like just recognizing what COCO is and what COCO isn't allows us to make informed conclusions about what we can know and observe from it. On that note, I do have I do have all the submissions open across
Oh boy.
across various tabs here.
I'm mildly frightened about what we're going to see.
Yeah.
All right, let's go through them.
Let's do it.
Yeah.
As they say in computer vision and elsewhere, YOLO.
Okay, so I've kind of got it queued so you can't, so we won't be able to see all of them all at once, and I'll have to refresh one by one. Great. All right.
Wow.
Here's the first submission. Is everyone? Yeah.
It's like a pufferfish balloon.
This was a kite. See,
pufferfish kite.
Yeah, that's good.
That's
okay,
quite
I gotta
a kite.
go rapid fire.
It's a good one.
Got,
some sculpted anime figs with a pizza of some kind. I like it.
Banana head.
Another hey,
love it.
A fellow second banana. Love it.
A suitcase head.
Suitcase head. That common thing that everyone's aware of.
Right. Somebody went for the head theme.
Person in the blender.
Huh. Camouflage furry.
A camouflage teddy bear.
Yes,
some
teddy bear.
Pink horses.
Those are.
Oh,
Saint Snippa and Rose, I guess.
That's great.
Dog
dinner.
birthday.
Oh,
that's is that Tim Robinson from I Think You Should Leave? It looks a lot like him. Wowzers! Wow, good semantic tagging on that one.
Some sloppy steaks over there.
Yeah, that's right. Just gonna slap them up. I got my
intersection of Obama and the Presidio. Do you really?
Yeah. Look, I'll bring it closer to the camera.
What was the?
That's great.
That's an interesting one.
Yeah, some guy with a knife and a mask.
Yeah.
Person by the a cow in a car. Cow in a car. I do love that. Banana on an apple. A cat checking itself out. A giraffe balloon. A man snuggling with his dog.
Oh, okay.
The man on the correct apple and send me here. Oh wow, there's mates.
What is that?
Oh, cats and a knife. That's threatening.
Yeah, it is.
What is this? A figure rotation? I don't know.
Lovecraftian almost there. I think that's a shuggoth.
Oh wow, this is weird.
Ken dolls on are they toilets? I don't
want to know the text that generated
the provenance of that one. Yeah, I'd rather not know. The sad toaster.
Last one that was, and then the last one was this vehicle. Okay, so those are our submissions that made it in time.
I think I have to defer to our guest to choose the winner here. These entries are all too strong for me.
There's a lot of good weirdness happening here. I think where I will land on most bizarre. That's weird. Where was it? Yep. Person in a blender. I see it. I verified it.
All right.
Yep. Okay. Right.
Congrats, Ken. Person in a blender is our winner this week. Please send one email to phil@opencv.org, and we will make sure that you get your RoboFlow swag pack. Congrats.
Great work.
Yeah.
Great work, Ken. There's a lot of good ones there, to be clear. This is quite arbitrary judging, so
yeah. Yeah. Well, I mean, you gotta you deal the hand you're dealt, or whatever, however that goes. You can't get fooled again, is how it goes.
It's called golden judging. The one who has the gold, makes the judgment.
That's right. A couple quick things. One, OpenCV AI scavenger hunt week 4 just wrapped up. Our winner is Lay. Good, congratulations, $125 weekly winner. We will be announcing the grand prize winners next week on this show, so tune in for that. If you want to be notified when we do the next one of these, or maybe something really similar, something really soon, hint, 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 go to opencv.org/hunt. If you'd like to try out RoboFlow, go to roboflow.com/opencv so we get those credit. Joseph, Thanks so much for being on the show. Satya, you got any last thoughts for us this week?
Well, I just want to thank Joseph for this incredible. I really enjoyed today's show and all the stuff we got to see. Yeah. And I wish all the best for RF 100. It is going to be an incredible asset for the community. It is data set of data sets, and we will see how different architectures perform across these different data sets. So very excited about this. Congratulations again, Joseph, for this amazing piece of work by your team. And thank you.
Yeah, of course. Thanks to the community making it possible. Bill, take us home.
Yeah, you bet. Thanks so much for joining us out there in the audience. We couldn't do this if you didn't watch it. We will be back next week, Thursday, 9 a.m. Pacific. I'll be back in beautiful, fragrant downtown San Francisco in my usual studio. Have a great day wherever you may be out there.
All right. Thank you, guys.
We did it. The show, as they say, must go on. Thank you for being our guest again on episode 80, Joseph. We'll have to pencil you in for episode 100. I think it's only fair.
That'd be so fun.
Maybe we'll do a panel discussion or something for episode 100. I haven't really decided yet.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.